All right, so the topic of this week's lectures was emergence and re-emergence of diseases. And a lot of the focus was on new pathogens and evolutionary mechanisms that can lead to either changes in pathogens or evolution of entirely new pathogenic organisms. But re-emergence is a very big problem as well. Expansion of ranges, introduction of pathogens into new areas, and we've talked somewhat about those, some of the mechanisms there, not least of which is people moving around the world, the global connectivity. We've talked about that in the AUA before. But I think one of the points that we haven't talked about very explicitly is the role of the changing globe itself, the global climate change, changing environmental conditions, globalization, urbanization, etc. So I just want to put that out. To what extent do you guys think that climate change and broad-scale global change is facilitating either the emergence of new pathogens or the re-emergence and expansion of existing pathogens?
So I think malaria is an interesting case. It's been one of the sort of poster children of the climate change debate. Real concerns about the extent to which changes in climate, warming temperatures might increase the transmission of malaria, whether that will increase the intensity in areas where there's already transmission, or will it lead to subsequent spread and re-establishment, or changes in range, possibly into new areas or re-establishing areas where it's previously gone extinct. And so I think there are a number of sort of interesting elements to that. First of all, that diseases like vector-borne diseases are strongly influenced by environmental factors, and that's because they're linked very critically to the ecology and the biology of the mosquito, and these are small, cold-blooded organisms whose biology, physiology, lifespan, what they feed on, how regularly they feed, is strongly influenced by environmental factors. So when you have small changes in temperature, that can influence whether your mosquito lives for 2 weeks or 3 weeks, how many eggs it lays, how quickly the larvae develop, and so on. And how well the disease incubates inside it. Very strongly temperature dependent. Does it take just 1 week to get through, 2 weeks to get through, 3 weeks to get through, and so on? So clearly environment is a very strong driver. One of the challenges, however, is that there are many other factors that are also drivers of the disease itself. Not just of transmission, but whether we have it or not. And if you look at climate suitability, if you look at climate maps, you can go down to Florida, or if you can go to the top end of Australia in Queensland, and you can see the perfect environment for malaria transmission. But there is none. There used to be, but there isn't any anymore. And that's because there's now, in some places, this disconnect between environment and transmission through economic development, access to good public health infrastructure, new houses, air conditioning, screening, people sitting indoors watching TV rather than sitting outside on the veranda. So all of these factors contribute to massive change in disease risk, disease transmission. In some places, however, you don't have those changes, and so environment is still a really key driver. And so it's not a very satisfactory answer, but unfortunately it's really rather complicated. There are places where you might expect small changes in climate to have a big impact on disease, particularly areas which are at the sort of edges of range now, where perhaps climate isn't quite suitable enough, but just a small change in temperature can lead to establishment of the disease. Or it can change it from where maybe transmission is suitable for 1 month a year, and suddenly it can become 3 months a year. And those sort of areas you might expect to see emergence and re-establishment of disease. But then even then, that's subject to where they are. If that's in Florida, it doesn't matter.
Well, and we oftentimes shorthand climate change as global warming. And that sort of simplifies the range of possible environmental changes that might occur in any given place. So we might have some places will warm, some places will get colder, some places will get drier, some places will get wetter. And so the ecological niche that creates suitability for some of these vectors and some of these transmission mechanisms is simpler than just a single dimension, right? It's just being warmer doesn't necessarily mean more mosquitoes. You also have to have enough water that you have aquatic breeding sites, right? Because they may be limited by the availability of larval habitat.
And Matt's done some very nice work showing that in fact even changes in the diurnal temperature variation during the day, no change in the actual average temperature in the day, but the extremes during the day is enough to radically change disease risk. So very subtle variables can make a big difference.
And you can achieve, and so we tend to think about global change, and we talk about climate change and what's going to happen, with the 2 to 4 degree changes in mean temperature over the next 20 to 50 years, as Andrew said. But that's only going to tell you part of the story, because perhaps patterns of the extreme events and the patterns of the fluctuation are as important as the shifts in the mean. But also you can get changes, very local habitat changes, overnight. I mean, if you have your household environment and you go to a sort of traditional mud thatch house in an African village and you put a tin roof on it, you've changed the indoor environment overnight. You didn't have to wait for 50 years for climate change to alter the environment in which that mosquito is resting. So we have, and you were saying, I mean, absolutely right, that availability of breeding sites, water, for instance, you can change the availability of water by putting in an irrigation scheme or draining a swamp. That can happen overnight. So some of these really important drivers of environmental change aren't on sort of decadal timescales, but they're happening now and having potentially really big impacts.
Air conditioning.
Right.
Yep.
Right. And in fact, there are cultural practices that that humans the style of housing, whether or not we're air conditioning, et cetera, that actually sets the microclimate for some of these vectors, right? So one question is, are they broadly experiencing global climate, or are they experiencing the microclimate that's probably changing very rapidly as a consequence of economic development and broad scale cultural change?
Yep, transmission is very local. So what you do at a local level, at the household level, at the village level, changes in microclimate, changes in environment, changes in cultural practices, access to bed nets, all of those things have a very big impact. You sort of overlay on top of that these long-term environmental changes that can sometimes act in synergy and make things worse. Sometimes they can sort of cancel each other out, and that's kind of an interesting challenge, because we're doing interventions, we're having change short-term in a context of longer-term environmental change. And there's been some rather nice work trying to evaluate, for instance, the impact of bed nets. And in some environments, you can see the bed net, so people have put out bed nets and you've seen a decline in transmission. And actually, when you start to tease apart, well, what's been the driver of that? In some cases, you can attribute it almost solely to the bed nets. In other places, you can see, well, it's been the bed nets, but actually something else has changed as well. The environment's changed too. And there are areas that have paralleled it where you've had the equivalent decline and they haven't even put out bed nets. Mm-hmm. Other places where control hasn't been as good as one might have imagined, having given out that many bed nets. And it turns out that, in fact, the longer term environment has been, or the sort of more regional scale environment has been more conducive to transmission. So we've had an effect, but it's not been as good because in the background, transmission suitability has been going up. So if we don't understand these things, even like some of our short-term interventions, we don't really understand how they work, why they're not working as well as they might be, or in fact, we're attributing great success to something which is in fact partly attributable to something else.
Yeah, and again, I think the refrain for lots of this course is that it's to understand and to predict some of these very complex processes. We need biologists, we need an understanding of social and cultural practices, economics and development, and global change writ large, I think, to really grapple with the complexity of some of these problems.
Yep.